Okay, in this tutorial, I'm going to show you how to do the Term 2 Test 1 higher version. Okay? So, question 1. You are asked to estimate a calculations 310 multiplied by 5.04 divided by 0.489. Please remember, estimate means to round each number to one significant figure, not just by guessing. So many students did not round the 310 to 300, but they did the other ones. So, just to remind you, is to round to one SF, one significant figure. So, for first mark, in exam you will get more marks, but you must first show you are rounding them to one significant figure first, like that. So, then you need to show how you multiply the top number to get the numerators, which is 1,500 divided by 0.5. Because this is a decimal number, you can try and divide that number by 0.5. But much better way to do this is to multiply this by 10 so that it turns into 5, but to also make that in the same proportion by multiplying 10. So you've got to do that top and bottom, not just there. Okay? So that becomes 15,000 over 5. Then you can divide this using bus stop method. 5 going to 1, none, and 1 left. 5 going to 15, 3 times, nothing left. So 5 going to 0, 0, and 0. So therefore, is 3,000. So for the first question, 1 is 3,000. That is the estimate of a calculations, and it will give you a sum of 3,000. Number 2. Calculate 3/5 of £20. You must first understand that of means how many lots of, that is multiply operator. So to find 3/5 of 20, you could simply find what 1/5 is first, and therefore for find 1/5 you just divide it by 5, because you're sharing 5 parts and each part is worth £4. Then 3/5 will be 3 lots of the £4, and that comes to £12. So that's equal to £12. Okay? Question 3. You've got a pair of parallel lines, and there is a line going through like this. Whenever you see parallel lines and to do with angles, 2 words you should come into your head. First one is corresponding, the other one is alternate. So you need to spot where if the problem involves corresponding or alternates, or sometimes both, depending on how complicated or complex the problem is. So the angles given to me here is 125 degrees, and it's asking me to work out y. Well, this angle looks this way, this angle looks this way. Which term means looking at the same direction? Well, corresponding it is. So therefore, y is equal to 125 degrees as well, and the reason is it's corresponding angles. So in exam, do write a full sentence. They are equal because they are corresponding angles. So that's 2 marks for that question. Now on to number 4. We are told in this ratio problem, slightly different to term 1, that the cats to dogs ratio is every 2 cats there are 5 dogs. And we are given that there are 25 dogs. That means it's been multiplied by 5 times more. So the cats must also be 5 times more. And so there are 10 cats. And that's the working out. So in term 1, we gave you information about how many there are altogether. So you usually would add this and then divide by the number in total. However, this is the second version of what a ratio problem could come up in exam. So be very careful in reading the questions to identify which type of ratio problem this is. Okay, so this is the type 2, if you like. So question 5. I'm going to multiply 24.7 by 35. I'm going to do this using the Chinese method. Because there are 3 digits, 2 digits, I will do a 3 by 2 grids. So 3 by 2 you need to split the boxes diagonally, so you're halving each of the box. And then, if you've done it right, your number 247 should sit exactly on top, and there's no extra boxes left behind. So 3, 5 goes here. If you like, you can put a dot there. I tend not to. I usually do the dots at the end. So now times them. If you don't remember it, write times symbol next to the box. 7 times 3, 21. 7, 5, 35. 5 times 4, 5 times 4, 20. 4 times 3 is 12. 3 times 2 is 6. 5 times 2 is 10. And the last bit you do is you add them up diagonally. Like you do in a column method, you add the right hand side, the units first, whatever the column on the right hand side is. So this is the same, but you do it diagonally. So 5, 1 plus 3, 4, 2, 2, 2, 6, 6, 7, 8. So the answer is 8, 6, 4, 5. So now we need to see where the decimal point is going to be. There's several ways to do this. I'm going to show you a way that will work for everything. Take this number, do a 1-7-figure estimate that we did in question 1. This is roughly 20. This is roughly 40. So 20 times 40, 2, 4 is 8. Add the 2 noughts. We know our answer needs to be around 800. So, therefore my decimal point should be there so that it is closest to 800. Okay? So, that's one way of doing it. Another way to check is there is 1 digit after decimal, there's no digit after decimal, so therefore there's a total of only 1 digit after the decimal point. So you could do it that way too. Okay? So that's number 5. So number 6. So I hope you're finding this quite straightforward. So if you did this during the holiday and revise and you struggle, I hope this makes it pretty much quite easy. Okay, so hopefully in the test 2, I'm looking forward to seeing some very good results. So number 6. I love this question because usually over the last 9 years, the old exams, always we expand 2 sets of brackets. Well, at Excel, our exam board decided that, well, let's not make students think that we always only multiply by 2 sets of brackets. We can multiply by any number sets of brackets. So, for our GCSE, it would not, I hope it is only going to go up to 3, okay? But be aware, you can multiply any. So I'm sure anyone who can multiply this 3, you can multiply any number sets of brackets. So let's ignore that first. do the old-fashioned way, which is x times x, x times 2, 3 times x, and 3 times 2, to draw those 4 arrows, etc. So x times x is x squared, x times 2 is 2x, 3 times x is 3x, 3 times 2 is 6. So now that's these expanded versions of this set of brackets. So just like 1 times 2 times 3, you do 1 times 2 first, then you times the 3. So that's what I'm doing. I've done the 1 times 2 now. So now I need to times that by x plus 1. And to do this, you just have to make sure each term has times. Okay, and then do that one with this one, this one, with this one, this one, with this one, and this one, with this one. So how many multiplications would I have to do altogether? Can you see? Well, there are 8 multiplications. So let me show you. So 1, 2, 3, 4. And now 1 has to do the same. 1, 2, 3, 4. To those 4 terms. Hence there are 2 terms there. So let's do the x first. X times x squared, x cubed. X times 2x, 2x squared. X times 3x, 3x squared. X times 6, 6x. Then I add 1 times x squared. If you don't mind, I'm going to write it here. That's 1x squared. 1 times 2x, 2x. I'm going to write it here. 1 times 3x, 3x. And 1 times 6, 6. And I'm going to add them all up. I've aligned the like terms together. Well, except maybe here, you will see there are 3 like terms here. So add x cubed on its own, add 5x squared plus another x squared, 6x squared, and then 6, 8, 11, and then plus 6. Okay, I could have added this 2 first before I start multiplying. Maybe then I won't have that many terms here. But it's different preference really. So next time when I do a video, maybe I would add the like terms first before I multiply. So that's the answer. There is no like terms, so it's a cubic expression. Okay. So now on to number 7. So if there's any questions, just make sure you go on to show my homework, and you can send me a message if you are not still not clear. Okay. So number 7. Okay, this is one that I think out of the 10 questions, I really want people to be able to do this. It's to do with upper bound and lower bound. So a number has been rounded to 2 decimal places, and that number and the result is 4.76. So this number has been rounded to, okay? Not you're going to round this to 2 decimal places. So therefore, what could be the maximum and what could be the minimum before it was rounded? So there is a error. Okay, so what's the maximum error and the minimum error? So the question is, how big a range do I shift? And to crack this problem, it lies on the information that says 2 decimal places. So that means 2 decimal places, the accuracy is actually 0.01. And to find the range is go up and down. This is the range. This is how much is going between highest and lowest. So that means if I halve this, I would share equally up and down. So half that is plus 0.05 and down 0.05. So my upper bound therefore is 4.765 and lower bound equal to 4.755. And there's a way to write this neatly. So the number n, which is that, can be written, since I have a bound, I can use something called inequalities. That the number can be between 4.765 maximum and then 4.755. And that's when the question says, using inequalities, which is a hint, write down the error interval. This is the error interval. So look at this in a real life situation. Is if I was to make a rocket and I need to make lots of same pieces of wood. Oh no, not wood. We would use wood for rockets. So let's say metal. So I'm going to cut the metal 10 pieces. I'm going to cut the 10 pieces out. That means my machine, every piece it's being cut, it can differ within this range. They won't all come out as 7.76. One piece might come out as 4.761. One piece might come out as 4.758, etc. It will be in this range, but it will not be the same. So, if you're building a rocket, if they differ, and the difference is very much quite a big has a big impact, then when the rocket goes through the atmosphere, when it shakes, then it might come loose. So most company that makes rockets, their company name usually come with something called precision engineering, maybe. That tells you that this firm, this company, can cut those metals, whatever you can think of, will cut them in a more precise way where the error interval will be much smaller. For instance, it might be 4.765 and this would be 4.762. So much smaller error. So therefore it would provide a much more precise engineering, and then when the cutting is done, it will be very, very solid. It will hardly cause any vibrations, and the rocket is likely to go to the space without any loose components. So that's where the error or this part of the work comes in real life scenario. Number 8. Find the area of a trapezium. Well, if you know it's a trapezium and you're asked to find area, the first thing should pop up in your head is the formula for finding area of a trapezium. Well, fortunately, there is a formula, and a formula which my year 10 know very well is that there are only one pair of parallel sides in a trapezium. No matter how you draw a trapezium, there's only one pair. Add the parallel sides, I call them AB. Then multiply by how far they are separated, hence height. And then you halve it. That's the formula for finding area of a trapezium. So, what's the parallel sides? It is 5 and 3, so add the 3 and the 5 together, times by the separations, which is the height is separated by 4 centimeter, and then halve it. So, do the bracket first. 8 times 4, 32, halve it, 16. But remember to include the units. Might not be important in exam, because they are likely to write the units for you already. However, when you again go to work in the industry, units is vital. Okay, so 16 centimeters square. Number 9. This won't take long. 2 to the power minus 1. So this is a high tier. You are expected to look at this problem and find what have you learned in terms of rules, formulae that will help you crack this. Well, please understand that you can't do negative indices. So somehow you have to turn these negative indices into positive. And one way to do that is something called reciprocal. This is the same as this, 1 over. Not because this is a 1, so I do 1 over. So if you think it's that, no, it's always 1 over. Is what one reciprocal is. So 2 to the power minus 1 can be written the same as 1 over 2 to the power 1. So in the very old days when we didn't have calculators, when we can't do power of minus 1, we would have to do 1 over then 2 to the power 1. And you know over means divide, right? And 2 to the power 1, like any numbers, they all have 1 in it, but we don't write them. So basically 2 to the power 1 is just 2. So therefore the answer is a half, or 0.5 if you like, but half, they will accept this answer. And it's only for 1 mark. Okay, lastly, number 10. Let's go on to here then. It's standard form. Okay, we've done this in term 1. We just want to see how much you remember. And we will keep asking this sort of questions so that you always keep refreshing your memory. So there are 1, 2, 3, 4, 5, 6 zeros and a 5, 7. Standard form is always written as a number times 10 to the power of minus an indices. And that number must be between 1 to 10. Okay, but not including 10. So it has to be less than 10, but it can be 1 or more. Okay, so again, I can use inequality to show you this. So it must be less than 10. It can equal to 1, but bigger than 1. So, so if you understand that, that means my decimal point needs to move over to this point, because that will give me a number between 1 and 10. So it's 5.7. So I'm going to remove the A, and I'm now going to have a 5.7. How much I have moved to the right will give me the value of the indices. 1, 2, 3, 4, 5, 6, 7. Finished. So, is it minus 7 or plus 7? That's the thing. If I times that, 10 to the power of 7, that's going to give me 7 zeros. 10 million, basically. 1, 2, 3, 4, 5, 6, 7. Well, that's not going to give me 0.00057. So, what's missing is a negative. Because I'm making this real number bigger, I need to compensate it by putting a minus sign. That's another way to look at it. Okay, one more. And this is the final question for the 20 marks. So, 10b. 10b is a number that is not a decimal number, it's an integer. 367 followed by 4 zeros. Okay, where's the decimal point gone? Okay, that's the question. Well, if you think about it, when you go shopping in supermarket, £6 can be written as 6.00. Between the units and the tenths, there's a decimal point. So that's where my unit is. So after my units, that's my decimal point. Once again, I need to have a number times 10 to the power of an indices. So, or index. So I need to find a number between 1 and 10. So is it here? No. Here? No. Here? No. That's 367. That's 36.7. Now I've got myself 3.67. So again, that's 3.67. So how much I have moved is what my index value is. So 1, 2, 3, 4, 5, 6. This time I'm making a big number smaller, so I need to compensate this by making sure this is a positive value. So therefore, that's your semaphore. So, just to summarize, if I see negative, usually I'm working with bacteria. If I see positives, numbers like 6, I'm probably working with astronomy, astrophysics, anything that is quite large in size. I mean, it's planets, that sort of thing. Maybe also speed of light, so that sort of thing. So that's one way to look at it. And so this summarizes all 10 questions. So thank you for watching.